First of all, Assalamu Alaikum, student. Today we will discuss about SEM, scanning electron microscope for in SEM in aluminum doped cobalt fluoride. Why we use SEM for aluminum doped cobalt fluoride for any sample? Purpose SEM is used to examine the surface morphology, means surface features, particle size at the surface, grain structures, and the degree of agglomeration. What is agglomeration? Means clusters of atoms of aluminium doped cobalt fluoride. Morphology. SEM provide detailed visualization of the particles, shape, and surface. Particle shapes and surface texture. In morphology, MCM provide data about morphology means particles, shapes, and surface textures. Aluminium doped cobalt fluoride typically exhibit the shape of a particle is spherical or slightly irregular shapes. Shape of aluminum doped cobalt fluoride particle is spherical or irregular shaped. Irregular shapes. If anyone अगर कोई आपसे पूछता है कि इसकी शेप क्या है, if anyone asks your question what is the shape of aluminum doped cobalt fluoride, then the answer is spherical or slightly irregular shaped. When aluminum doping, then grain influence the grain growth. Grain growth leading to smoother means shape of particle we get in smooth form, more uniform surface, more uniform surface when जब doping of aluminum due to non-magnetic ions. SEM particle size can measure the particle size distributions. SEM can measure particle size distributions. Aluminum doping generally result in smaller particle size. SEM basically provide data about particle size distribution when job doping of aluminum then generally result in smaller particle size as compared to undoped cobalt fluoride due to inhibition of grain growth by the smaller aluminum ions. The size of particle is decreased by doping of aluminum due to aluminum ions which has smaller radius as compared to Fe3 plus ions, because Fe3 plus ions is replaced by Al3 plus ions. So this radius of Al3 plus ion is smaller, then the particle size is also decreased. The nanoparticles usually range from 10 to a few hundred nanometer. The size of particle range from 10 to few hundred means 10 to 100 nanometers, 10 to 100 at nanoscale. The size we get size of nanoparticles is in the range of 10 to few hundred nanometers. Grain structure. SEM reveals the arrangement of grains in the material. SEMs provides data about grain in the material. Doping with aluminum refined grain structures, which can enhance certain material properties like density and mechanical density. SEM also provides data about grain in the material. Doping of aluminum gives uniform grain structure, means refined grain structure. Agglomeration. SEM image also highlight the degree of agglomeration, which is common in magnetic nanoparticle due to strong magnetic agglomeration show due to strong magnetic induction between the nanoparticles. This is the basic properties of nanoparticle, magnetic nanoparticle due to strong interaction, magnetic interaction, strong agglomeration. Aluminum doping may reduce agglomeration. When jab aluminum doping, then agglomeration process decrease because aluminum is non-magnetic ions. also affect the structural properties, but some clustering still occurs. Means some cluster or group of nanoparticles also exist due to magnetic interactions. Some magnetic interactions. But agglomeration decrease uh, until still present due to magnetic interaction. Additional analysis. SEM can also can be combined with EDX, energy dispersive X-ray spectroscopy. SEM can also be combined with EDX, energy dispersive X-ray spectroscopy to analyze the element composition. Confirming the presence and distribution of aluminium, cobalt, and oxygen in the sample. If we check the presence, confirm the presence of aluminium, cobalt, iron, and oxygen in the sample, then we use EDX. EDX, energy dispersive X-ray spectroscopy. EDX stand for energy dispersive X-ray spectroscopy. Why we use EDX? EDX is used to confirm the presence of some some chemicals, aluminium, cobalt, iron, and oxygen in the sample. We check element aluminium, cobalt, iron, and oxygen in the sample. Then we use EDX and compare with SEM analysis. SEM provides comprehensive data on physical aluminum dot warfare, including SEM basically provide data about particle size, shape, and structural feature. Morphology feature means structure at the surface. Surface feature, particle size, shape, grain, agglomeration. This data is given by SEM analysis.